So in this video, I'll go over how I generated the huff lines to detect the shapes on the left and the right lane lines. And then I'll go over how I picked a single individual huff line to detect the left and the right lane lines, and then test those on 5 different videos. So first, using the line image function, I use CV2 huff lines, where it uses NumPy to go into cosine and sine and use 2 different lines to detect if the slope is greater or less than 0. And then using BGR, it would either put blue on the left or green on the right to detect the 2 different lines on the right and left. So if I run this, I will get a lot of lines on the left and the right, and the goal is to pick a single line that would then go over each individual frame of a video and detect if it's inside the left or the right lane. So next, I want to choose a single individual lane line out of all of those huff lines to be the single one that would be on top of the lanes. So I changed the bulk of this line image function. I created open arrays for the left and the right lane lines, and then I converted back from polar space into Cartesian coordinates. Using the a and the b of cosine and sine, I could find the slope and the intercept. And then using these left and lane lines, I would then add each individual frame into that array using these index values of these 2 different left and right lane line arrays. Then I'd use NumPy to find the median slope and intercept of those indexed arrays. And then using the Y range, I could then shorten it at the top of the horizon of the camera, which is something I did pretty much through the all 5 different videos. Then using CV2 line, I could draw the line using those calculated y-intercepts and x values, and then finally drawing the left and the right lane lines. So once I run this, I will get 2 very distinct lines on the left and the right that would detect if it is within these 2 lane lines on the right and left in green and blue, respectively. So then, using the CV2 video capture that we have in the lecture slides, I could then test this on the first test video. So if I run that, I get this, which is looking pretty good. The right is solid, so it detects those shapes much better than the ones on the left, which are dashed, and so that's why you get sort of a blinking effect. Here I kept the thresh value at 60, the kernel size still at 3, and so pretty much for the first test video, everything runs about as I expected. So next, in this second test video, I did have to change things up a little. So going counterclockwise from the bottom left, I changed the top right portion of the mask to create a better mask. I added 10 pixels to that. I raised this thresholder value to 140. And other than that, I sort of kept things pretty much the same, the kernel size and everything like that. So if we run this, I get sort of a better blinking than I did on the first. I kept this edge video up so you can see that it's detecting these shapes rather well. You still get blinking from the left and the right, but that could be because you get a higher transparency from the camera. There's a lot of noise from the bridge, but on the right lane here, it's still solid, as you can see on the edge image. And on the left, it's still blinking because it is still a dashed line. So for the third test video, I kept the mask the same from the second one. However, I did increase the threshold to 150 because on this third video, there was a rumble strip on the left side of the road, and that added some noise that would sort of cause the left lane to experience a bit of an issue. So if I run the third test video, it sort of has some issues at the beginning, but then it sort of straightens up really well. You can see that the rumble strip on the left side has been eliminated from increasing the threshold value. And one thing I noticed in this one is that I think it's driving faster. The car is moving faster than the previous two videos. And so it's picking up these dashed lines much better than previously with the other dashed lines where the car was moving slower. So this was probably the best one that I had of the test videos because I think the car was moving faster. So it was able to pick up those shapes much better. So this the first homework video was probably the one that caused me the most trouble. To start, the mask needed to be completely overhauled, as well as the snipped image. So it was recorded on a different camera at a different car. So the entire framework of my mask pretty much needed to be changed. So I labeled them 1, 2, 3, 4, 5, and 6 from the bottom left, going counterclockwise. This gave me a much better view of the car itself. I moved it up to eliminate the hood of the car, and then I narrowed the horizon to cut off a lot of noise on the side of the road. I increased the threshold, or rather I kept it the same from the third test video to 150. This road was not very well maintained. There's a lot of tar all around the road. So I also increased the kernel size to sort of eliminate the rumble strip on the side of the road, as well as all of the unnecessary lines that were really causing me some issues. So when I run this, you can see it's a much bigger video. There's a lot of tar in the middle, which I eliminated by upgrading the blur with the kernel size. I created a mask that would eliminate this hood of the car because it's much more protruding out than the previous other videos. And I'll run that again, actually. And the rumble strips here, along with a lot of the tar strips in the middle of the road, would cause this this left lane line to not read as well. Additionally, it's dashed, and the car isn't moving as fast as I think it was in test video 3. So lastly, in the last test video on the homework 5.2, I did adjust the mask again. I moved it down to eliminate the car that was being followed in the front. And then I narrowed the horizon because I did want to cut off the bike lane on the top. And then I also brought in the bottom right of the mask to eliminate the bike lane that would sort of come in very close to the shoulder towards the end of the video. I used 140 as the thresh value, which was the same as I used for test videos 2 and 3. I was able to lower the kernel size for the blur because it was a much smoother road. It was better maintained. And then something I forgot to cover with the other ones is that I shortened it by about 20%, which compared to the other one, which was about 18%, and the other videos, I pretty much kept around the same at about 40. So if I run this one, it's very smooth. The right lane is not reading this bike lane in the middle. I was able to cut off this car in front, and the dash lines are not being read on the left, but rather it is the straight line in the middle. Here's about where the bike lane sort of gets very close to the other shoulder, and I was able to eliminate that by changing my mask.